Hello YouTube. In this video, we will create a simulated web server and simulated web browsers in order to demonstrate how multi-threading can make your web server much faster. At the server side, we created socket which listen on the local host port 8090. Once there is a new connection, we handle the request. What we do is we print out which thread is handling the current request, and we simulate the calculations with 2-second snip. After that, we close the socket so that it can be reused. At the client side, we simulate the web browser with a curl command. The curl issue a GET to the localhost port 8090. We want to issue the request concurrently, so what we do is we create 5 requests and put them as the background. So this command just created 5 concurrent web requests. And after waiting for the last one finishes, we benchmark how much time has spent. So let's run the program. Oh, it's already in use because I ran this program before, so I need to stop this and run it again. Now the web server is ready to serve the new connections. Let's issue 5 concurrent requests. As you see, all the requests are handled by the main thread. This is the parent thread. And if we check the client, the total time spent is 10 seconds. Even though we issued the web requests concurrently, they are handled one by one. The reason is we have a single-threaded program. We only have main thread handle threads, so if you have more than one request, they have to wait. We can make this web server much faster by using multi-threading. Okay. Instead of have just one thread, which is main, we can create a new thread for each request. The thread need a runnable. Let's create the runnable. And in this case, we have 5 threads serving the requests instead of 1. So in theory, the web server should be 5 times faster. So let's check it out. Okay, as you can see, it only took 2 seconds to serve those 5 requests because we are using concurrency, and there are 5 threads handling the requests, so they run in parallel. We only need 2 seconds. This strategy have a serious limitation because if you create a new thread for each request, you could quickly consuming all your hardware resources. Say if I have like 1000 concurrent requests, you need to create 1000 threads. And that could be a very stressful moment for your hardware. Besides, create a new thread need resources. Why not reuse existing threads once you finish the handling? So in this case, you need a thread pool. We use the executor to create a thread pool. So here, let's have an executor. Exec equal executors. Executors is a factory class. Allow you to create some pre-made thread creation strategies. So in this case, we need a new fixed thread pool. We can say how many threads you can allocate it to serving your web requests. Of course, we need to import. Here we say maximum. We only need 2 threads at any time. And Then we delegate the thread management to our executor. So instead of creating the thread for our own, we just delegate it. Okay. The execute expect a runnable. Let's give it the runnable. In this case, the thread pool is handling our requests, and the thread pool size is 2. Let's run the program. Issue the same requests. As you can see, this time we spend 6 seconds to handle those 5 requests. At the server side, we only have 2 threads at any time because we have the limitation of 2. That's the advantage of thread pool. We can even make the thread creation process more customizable by providing our own executor. In order to do that, we need to overwrite the execute method. Okay. So say, how do you want to, what do you want to do if there's a new runnable get executed? In this case, we want to create a new thread to run that runnable. So by doing this, we go back to this scenario. 1 thread for each request. And of course, we don't need the customized executor. So we can delete this because we created our own executor. Pre-customized. Okay. Console. Let's run it again. Here, issue the same. As you see, 2 seconds. As before, we have 5 threads, each one for each request, like this scenario. On the other extreme, we can simulate the single-threaded scenario. Instead of running in different thread, we run the runnable in the quarter thread. Okay, then we go back to the single-threaded scenario. Let's check it out. Stop, start, and issue requests. As you can see, they are all handled by the main thread, which is a quarter. And if you check the time spent, exactly 10 seconds. So we have demonstrated how the multi-threading make your web server running much faster, and we can also tune the thread creation strategy, either using pre-made executors or create our own executor by overriding the execute method. Thanks for sitting through this video.